Hello. In this video, I'll be showing how using Spring Boot you can quickly come up with a bare bones application which is production ready, and then start working on the problem, the business problem at hand. So, Spring Boot is one of the many projects under the Spring ecosystem. What is special about it is that it combines various projects which are under Spring and also some libraries which are outside of Spring ecosystem, but provides a good set of features for a production ready app. So as part of this video, let's begin with how do we start with a new application, how we initialize the first few lines of code. So for this purpose, the Spring Boot has a Spring initializer at the URL start.spring.io. So here when I go, I have selected the Gradle project. By default, this version of Spring Boot is the latest one, and I have given the name of the artifact as greeting, and there are various dependencies that you can include as part of this. So the ones which I will be using is web, and then since I'll be building a REST API, I need things like JSON marshalling, unmarshalling, and some validation, a mechanism to expose the REST URLs, and yeah, so all of those are provided as part of web. I don't have to care what all is under that. It's mostly Spring ecosystem projects along with some few libraries. I also, since I want a production ready app, I want to be able to monitor it. For that purpose, there is this actuator, and I'm also thinking of including one more library, which is Lombok. And I think so these three libraries as of now are sufficient for me to start the project. So I'll just generate the project, and what I get is a greeting.zip file. So yeah, so this is all I have to do just to do the initializing a new application. At this point, I have a full-blown application with all the bare bones setup and all the things most of the things which are necessary for having a production ready API. So let's see whether we have that or not, and see how the packaging and running happens. So let's straight away hit to the terminal, and we have this greeting.zip and the downloads folder. So the first step, what I'll do is unzip the greeting.zip, and as we see that it has created files in the greeting folder, I go into that folder and just clear my console, and the first thing to do as a package is I have Gradle. I had selected Gradle, so I have this Gradle wrapper which I can use to run, and I will run the command Gradle w build. So this will basically build my whole package, run a set of tests against it, and to ensure that everything is fine, and give me an artifact output which will be a jar. And the next step as part of running the application would be running the jar. So here you will be able to see there are some tasks which are mentioned. Some of those tasks are provided by a Spring Boot Gradle plugin that has been automatically configured as part of the build that we downloaded. So we have an artifact now. Let's try to run it. The artifacts get built and gets deployed at this folder, the build libs, and it's called jar. Now for this to run this jar as a Java jar, there needs to be a manifest with a main class declaration. So that is done by the boot repackage task here, which again comes from the Spring Boot Gradle plugin. So I run this Java jar, and the next thing I see the application running. If you notice, we have a few things like we have an embedded server which has started, and that server which has started is the Tomcat running at port 8080. Now, uh, the other thing you can see is we have some of the logging configured. Until now I didn't have to write even a single line of code. So at this point, we know how this packaging is done and how we start running the application. Next, let's see the logging. This logging is a very important feature, so that you can come to know, okay, what is happening on a production system when you're running and things might not be going correctly. So what Spring Boot is doing here is that it has automatically configured the logback logging framework for us, and also it has given a sense, like some sensible defaults, wherein the pattern for the logs, like the timestamp followed by the logger level, the process ID, and the thread which it is running. So all those things are configured. I didn't have to write anything to get that to get to this stage. So till now it's all the sensible defaults which are configured by Spring Boot. So yeah, the so that covers the logging part. Let's see, the next is the externalized configuration. So Spring Boot is not only giving us sensible defaults, but it is also giving us a way to modify those sensible defaults and do and give you a flexibility to change those via some configurations. So let's make one change using a configuration. So here, if you see, again we have the Tomcat running on port 8080, but now I want to instruct Spring Boot to not run at 8080, but instead start running at 1990. So what I will do is use I have options to use environment variables or system variables or command line arguments. So let's begin with the environment variable. There is a property called server underscore port, which I will configure as 1990, and then give my command, the java jar command, to run the application. So here, when we run it, we have specified the environment property. Now Spring Boot will pick up that environment property and see, okay, something has been provided as an environment, so it will override the default configuration, which gives us 8080. And if you see here, the Tomcat has started at port 1990. So that was one way of configuring. Let's say uh, we did by this way. Now we want to give another way, where I want to give it as a let's say system variable. So what I would do is java -d server.port equal to 1980, and then uh, give the jar which needs to be run. So now if you notice here, this is how some of the environment variables cause problems when there are dots in that. So there is a default way of using underscores. However, we can use proper namespacing while we are using system variables. So we give server.port. So Spring Boot by default has this capability to read properties either separated out by underscores or properties separated out by dots. So this is all convention, and so we can get the most benefit out of it. Yet another, there is another third way to do it, and that is by giving command line arguments to the jar. So what how we do that is by giving the jar and then calling the uh, command line argument, like server.port is equal to 1990. Let's run this command and see whether it actually runs at the 1990 port or not. So here, yeah, Tomcat has recognized that, okay, I need to run on 1990, and here it again has started at 1990. So this covers the external configuration, and like how Spring Boot is giving us external configuration to make changes to the defaults. The other feature is monitoring. So when we were configuring a new project, what we had selected, one of the artifacts was actuator. So what actuator does is gives us a few URLs uh, that helps us in seeing how the system is working. So one such URL, let's see one such URL that gives us this, and that feature is I'm calling HTTP to localhost. The current port that I'm running on is 1990. So I give that, and let's see, we have a health URL. So I'll give a flag of verbose so that it prints out the request and response bodies and the headers. So uh, so it's running for the first time, and here we see that okay, get health has been called, and the tool that I'm using HTTP is the HTTP IE, which gives good formatting so that I can understand what is happening. And here it returned with a few of the properties with around disk space and whether the service or the application is running or not. So this is something which I'm getting by default by just including the actuator library as part of this project. Another one such, there are many other URLs, but there is one more URL which is basically giving us the metrics. And when we run this, we see, okay, how many classes have been loaded, how many threads are there, and what's the uptime for the application. So these are all things which help us very much on the for monitoring on the when systems are running in the production. So there are many other URLs, and you can use them for finding out various issues that you might face on production. And now let's see how all of this, what all that I showed till now, how all of that is working. What was the code that was generated as part of the greeting.zip that we downloaded, the greeting.zip that we downloaded from the Spring initializer. So for that, let's open the code. So the since I had used Gradle, I can use it, open it using build.gradle. I've configured my laptop to open build.gradle files using IntelliJ. So yes, so the application has come up. Now as part of the source code that we got by default, let's walk through each of the classes. The one was greeting application. Since the name that we gave to the application was greeting, so it created a class called greeting application. It has been annotated by it's been annotated by its Spring Boot application, which Spring Boot understands that okay, whenever this class is instructed to initialize, I will do configurations as part of this. Let's go into this and see the annotation enable auto configuration. This is the annotation which is responsible for doing all the default configurations. Things like running an embedded Tomcat server, giving you some sort of validation framework, having JSON marshalling and marshalling features using Jackson. So all of these are given by the enable auto configuration tab. So uh, as part of the main application or the main method, we are using Spring applications run method and passing the class, and any command line arguments that were passed to this main are passed on forward to the Spring application. So this is the only configuration or the only class that had to be written to run all of this till now. Okay, the main component or the main the file behind all of this is which brings all the libraries is build.gradle, and here we see that we are running against Spring Boot version 1.4, and this includes a Spring Boot Gradle plugin which gave us tasks like the boot repackage which we could use. And here if you see the libraries which are included are the actuator, the Lombok and Web. These are the ones that we had selected while coming up with the project Web Actuator Lombok. And this is by default included by Spring Boot Starter. This is by default included by Spring Boot, so that it gives us some testing capabilities which we will be covering later. So as part of auto configuration, that is all we needed for all of the application that we ran till now. So just a few, it's a couple or 3 or 4 lines of code. That was more than enough. So let's move on and see what are profiles and how it helps. So we saw that we gave so Spring has a way, Spring uses Spring profiles to do loading of an application in some slight different manner. So let's define one such profile. So what I'm going to do is, okay, before defining, and under the resources, there is this application.properties. So this is used to configure the behavior of Spring Boot. So things like we saw an example where we gave server.port from from the command line using environment variables or system variables or command line arguments. Uh, Another way of providing those features, if you want to embed that into the application, is using application.properties. So how you define is like server.port, and you say, okay, I want to run on, let's say 90, I want to by default run on 8080. There are many other properties like let's say Spring. Uh, Under the Spring namespace, you will find many property configurations which you can use. Similarly, there are so you have Spring data source, which is needed for database configurations. Similarly, there are like multiple configurations that you can give. How where profile comes in is, let's say by default you want to always run on port 8080, but when you are running on dev environment, let's say you want to run on 9090, and but rest other properties need to be picked up from the by defaults. So we want to override, and that is where we use profiles. So let's define one new profile. What we'll say that so again here we are using a convention that it will be application and then forwarded by the profile name, which is the dev in this case, and the file is application dev.properties. Similarly, we give a server.port, but now this time we'll say that we want to run it on 1990. So let's bring up the application first by not giving any profile, and second by giving a profile, which in this case would be dev. Now we have been running till now by packaging and then running the application by Java jar. When I am doing development, I want to combine both the steps together. So Spring Boot Gradle plugin also provides me a task called boot run, which helps me do that. So that let's see. So this boot run will run will do the will build the package and run the main class as part of it. Will find the main class and then run it on the command line. So here again we see that the server has been initialized on 8080, because here it is since we did not pass any profile name, so it has assumed a default profile, and default profile means that the files will be picked up from application, or the properties will only be picked up from application.properties. Now let's let's give a let's run the application by giving a profile. So we have another property for it when defining the profiles that Spring should use. So it's called spring.profiles.active, and we say our active one is dev, and then we run our application using boot run. So here what would happen is, since the profile is dev, all the properties, first this application -dev will be looked for the property configurations. If those are found there, those will be considered, But if something is not found in this file, it goes to the application.properties to look up for the like configuration values. So uh, let's run this and see whether it has picked up the profile correctly. So here, if you look carefully, uh, Spring Boot has seen that okay, the following profiles are active. So the active profile is dev right now, and if we scroll down, we see the Tomcat is running on port 9090 because it was defined uh, in the application dev as 1990, and it overrode the property which was defined in the default application properties.file. Yeah. So this is how Spring uses profiles, and this is not just limited to properties. You can conditionally bring up a few implementation of services based on the profiles you define. You can have a single application for multiple of your clients, and you can differentiate those clients using these profiles. So there are many use cases where profiles fit. So the last part, let's see how testing is made easier, how testing is supported and it is made easier by Spring Boot. So let's say in our application, we have this feature where someone can post to a URL, and while posting they pass in their name, and along with the name, the response for that we get is like greeting the person with the name, like calling hello and that name. So let's see how we can do that. Uh, so we can begin by writing a test for that. So let's see, as a part of default code, we got one class which is the greeting application tests. What this test is doing, it is just checking whether my application is loading properly or not. So if application loads properly, there is no exception, and hence this test passes. But for the application to be loaded, and um, it needs we need to instruct the test to use or to some way initialize the Spring framework. So there are two classes like the Spring Runner and the Spring Boot test combination. Using these two combination, we can instruct uh, the Spring Boot to start an instance of application for the test and run our tests against that. So let's define a test for the functionality I had just talked about. So we can call it our greeting API tests. So again, since we want our application to be running from Spring, we will give it a name called Spring Runner. We'll run with Spring Runner dot class, and also we will tell that it is a Spring Boot test. Now let's define the test name. So here what our test is doing, that it greets with the provided uh, name. And so let's see, now for calling the API, we would need some sort of REST client, and Spring provides some mock MVC, which is again a REST client, plus it gives some various methods for assertions that you can do in a fluent manner. So we will inject one mock MVC, so uh, that will be mock MVC. And here, now for this auto wiring to work, we have to tell the Spring application to auto configure mock MVC. So there is an annotation for that, and let's start with the test. The first thing that we will do is mock MVC, and we will perform a post request. So and we perform, let's say we are exposing to a default URL which is slash. Now this post is provided by what we will be using is the mock MVC request builders, and it basically provides various static methods which we can use for building it. So post, we need to post some content, so, which will have a content type. So I'm saying it has a content type of application JSON uh, UTF-8, and also I am posting uh, uh, some content body which wherein in which I will be passing on the name. So the method for passing on the name, let's say I am passing an attribute called name, which helps me identify the name of the person who I need to greet, and let's say that the name of the person is Spring Boot in this case. So when I call this, what do I expect from the service? That it should return me with a status indicating that it is a success. So this status is again, I'll be using mock MVC result matchers to do that. So here I have done a static import for that, and I am expecting that the status should be a success one. That should be okay, and I want the body. So there is another JSON path in the result matchers which I can use to do assertions in the body. And what I'm saying that whatever JSON I receive, it should have a key with the name message, and it should be value, and it should be equal to the value hello uh, Spring Boot. So this completes our test. Is a class which is exposed by another static class given by Hamchrist matchers. So I'll run an import for that, the Hamchrist matchers, and so this completes our test. Uh, Obviously, when I will, since we haven't implemented this API, this is the business logic I'm building. Till before this point, it was all infrastructure, which was given to me by default. On a normal project, I would have to make a lot of decisions. Okay, what is the best library for the functionalities that we need? Okay, we would need logging, we would need monitoring. What all should we monitor? What are the best practices? These have all been taken care by Spring Boot. What I am focusing on is just building the application code right now. So here the test is running, and it should fail, and it fails correctly by saying that I was expecting a status 200, but what I got was 404. That this URL is not there. Obviously it's not there because we haven't built it. So let's go ahead and build that URL. So let's make a class for greeting APIs and call it greeting controller. So since it will be exposing REST APIs, so I'll want to call it a REST controller. Now it exposes the functionality of greeting, and so and it is a post method. So I say I have a post mapping on the URL which is on the relative path, which is this. So what I get in return is a greeting response. The method that is called as greet, and the request body for this post request is a greeting greeting request, and uh, so let me return just null for as of now. What we will get is I'm creating a class for the request representing the request. Let this class be inner class as of now. Now I whenever a request will come, Jackson will be called, and it will create this class from the incoming request. So it should be able to create independently of greeting controller. So I have to put the static modifier. It will have a property named, if we look at the test, it expects a property with the name. So we will give that property type as string, and the property name to be name. I need to create getters and setters, and for that I will be using Lombok here. Since I'm using Lombok, I have to configure my uh, IDE to do annotation processing. So I am just enabling uh, annotation. enabling the annotation processing since I'm using Lombok. Now we get data here. The other class that we want to make is uh, the greeting response. Again, we look at the test. What we are expecting is a JSON body with a key message. So we give the same key here. We say that it is type string and the name is message. Now here again we need getter setters for Jackson to work, and hence we give the data. However, I also want to build this response myself. So I would like to have some of the Fluent's builder methods which is provided by Lombok, and hence I include builder as part of this. Now here what I say is return greeting response dot builder, and when I say builder I want to pass in a message. The default message, the prefix is hello with a space, and I add the greeting request dot get name, and then I finally do a build here. So this completes my API which I was building for the test. Now let's run the test again and see whether we are able to pass our test or not. So uh, uh, okay, I enabled the annotation processing, but I did not build the project again. So I'm building the project here. And, let's run the test. And, okay, so I missed the static modifier here, and yep, again this builder is a static method on the greeting response. So for that to be able to for Lombok to be able to put that method, we need to make this class as static. Let's go to the test and run the test. So one thing you would notice that when we were running our application from command line, all the logging level was by default info. But in our test, we need to do a lot of debugging. So it has Spring Boot has given a sensible default where it runs at a level of debug. So now if we look, our test has gone green, and the response that we get is a message hello Spring Boot with a status score of 200. So uh, we have built our first API. Let's bring a small change to the requirement. Now what we want is that it should respond with bad request error if name is not provided. So it means we don't want our API to just send nulls or empty hellos. So what we want is we want to perform, whenever we perform a post call to our API, uh, and we say that the content type is again application JSON, and the content that we are passing does not have a name attribute. Let's say we are just passing an empty JSON body. So at that time, I am expecting the status to be a bad request. Let's see, obviously we haven't built that functionality. So when we run it again, the test will fail. Uh, we, uh, we expect a status score of 400, but what we will get is 200. Let's verify that whether that is happening. Uh, so this Spring Boot initialization as part of test is only done once, and then the application is cached. So if there are multiple tests with Spring Boot, it wouldn't take much time to run. So here what you see is we were expecting 400, but what we got is 200. Now let's go ahead and implement this functionality, and let's see how using Spring Boot has made me or has helped me uh, build that functionality very quickly. So obviously what we want is whenever our request reaches this point, we want to be sure that the greeting request is valid. That means the name should not be blank. So one obvious thing that we can use is the Java validation. So there is an annotation named as not blank, which is provided by the Java X validation. Uh, or what Spring gives by default is a Hibernate implementation of validation provided by Hibernate. So this is not in the standard specs. So not blank is one which checks, okay, it's not null and it's also not empty by after trimming the blank spaces or the white empty spaces. So here I have marked it as a not blank. I have given that my greeting request should always have a name. Now I also want to ensure that whenever my request reaches this point, it should be a valid request body. So hence I have a at valid tag. If we see this at valid is the one which is provided by the JavaX validation. Now, this is the only thing that we need to do. All of the hooking in of the validation library, getting it to work, and getting it to scan various classes to pick up whatever configurations or annotations have been defined. I don't have to worry about it because it's done for me by Spring Boot. Now, let's see, go ahead and run both of our tests, and they should be passing. So let's go ahead and see whether what we expect is there or not. So now both of our tests are passing, and we have successfully built our first small set of functionality for our application. So I hope you will agree after seeing this that much of the concerns that we have to think about the production readiness of the app is directly taken care of Spring Boot by Spring Boot, and what we have to do is just generate a zip file using Spring initializers, start.spring.io, and we are ready to go ahead with solving the real problems.